Hello everyone. So today is our Lab 5, okay, superposition and the equivalent circuit. So before you start doing the experiment, please read through the lab manual, and if you have time, also watch those videos. Those videos are very helpful. And first of all, this week, so Lab 5 will be the first time you're going to write a formal report. Okay, so it will be different with what you've done for the write-up. There is the introduction video, like about how to write the report, and also there is a document, like tell you how to write the report. Okay, so please read through those documents before you start to write the report. All right. Okay, let's talk about today's lab. First of all, I want to talk about the pre-lab really quick. Okay, so this is the question. Okay, you will have you had wave 1, wave 2, and wave 3. You have 3 separate input voltage. Okay, and then you want to measure the output, or you want to calculate the output voltage. In this case, you will use the method called superposition. Okay, so you want to calculate the output voltage due to each input separately. Okay, first of all, let's see. First of all, I want to calculate Vout1. Okay, Vout1 will be the output due to only V1, okay, which is a DC voltage. It comes from the V plus of your AD2. Right, let's see. So if you only measure Vout1, okay, so then you need to short V2 and V3 to ground. Okay, so remember, when you do Vout1, V1 is only input, and you need to short this 2 port. Okay. And then you do the calculation. So we can transfer this circuit to something like this. Okay, because when this is the only input, okay, the current will go to R1 first. Okay, so this will be R1 right here. And then the current will go to R2, R3, and R4 at the same time, which means R2, okay, this should be R2, will be parallel with R3 and R4. Okay, so then this circuit will be like R1 in series with R2, R3, and R4 in parallel. And then this will be your Vout1. Okay, so your Vout1 will be equal to V1 times to R2 plus R, this should be R1, okay, in here. And R2 parallel with R3, R4, and R4. Yeah, R2 parallel with R3 and R4. And this should be R2. Okay, so this is a simple voltage division circuit equation. Okay, so this is a voltage division circuit. You have done something like this in last week. If you forgot how to do the calculation, okay, this is an example. You need to go back to read through the manual. Okay, and here is a simple example tell you how to calculate the voltage division circuit. Okay, so that's Vout1. Okay, then you use similar method to calculate Vout2. Okay, so let me for Vout2, okay, V2 will be your only input. Okay, so you can use W1 as your V2. Okay, W1 will be a triangle wave. So then you need to short V1 and V2 to ground. Okay, in this case, the current will go to R1, R2 first. Then the current will go to R1, R2, and R4 at the same time. So in that case, the circuit will be something like this. Okay, the current go to R1 first, then go to R2, go to R2 first, then go to R1, R3, and R4. Okay, so R1, R3, and R4 will be in parallel in this case. Then this will be the output. And since V2 is a triangle wave, okay, so the answer for Vout2 will be like a function, okay, a function of triangle wave. So Vout2 should be equal to like some amplitude times a triangle wave. Okay, so you have the frequency here. Okay, then you use similar method to calculate Vout3 when V3 is the only input. Okay, so then the final answer will be the total Vout is equal to Vout1 plus Vout2 plus Vout3. Okay, so that will be your final answer. Okay, this answer means when V1, V2, and V3 turn on at the same time, this will be your output voltage. Okay, hopefully you do this correct. So that's your pre-lab. Let's talk about the tasks. Okay, so for lab 5, you will have 4 tasks. Okay, the task number 1 and the task number 4 are related to pre-lab. Okay, so for task 1, you will build the circuit in pre-lab on your breadboard. Okay, so you build this circuit on breadboard, and then you follow the same step when you calculate the Vout. Okay, so first of all, you treat V1 as the only input. Okay, so you connect V1 to V plus and short V2 and V3 to ground. Okay, then you measure the Vout, that's Vout1. Like you can use channel 2 measure Vout, use channel 1 to measure Vin, and then you can take a screenshot. Okay, so for this question, you will have 4 screenshots totally. Okay, so the first screenshot will be V1 and Vout1. Okay, then you do the same thing. Okay, so you will take a screenshot when V2 is the only input. Okay, in that case, V1 and V3 is short to ground. Okay, the second screenshot is channel 1, maybe input of maybe use W1, and channel 2 is the output. Okay, that's Vout2. And then you do the same thing for channels for V3. Okay, so channel 1 is the sine wave, and the channel 2 is the output of Vout3. Okay, and remember, when you take a screenshot, you want to make sure you measure the peak-to-peak voltage and the average voltage by use the automatic measurement tool. Okay, so there should be 4 screenshots in total. Yeah, and for last screenshot is the total Vout. Okay, so since you are using AD2, the oscilloscope of AD2 only have 2 inputs. So when you measure the final Vout, you don't have to include the Vin. You only need to include the Vout. Okay, helpfully, after you measure the final Vout, the graph of the final way out should be similar with what you get from question 2 of your pre-lab. Okay, and let's skip task 2 and task 3 and talk about task 4 first. Okay, so task 4 is continue with task 1. Okay, so you are going to build the circuit into LT space. Okay, basically you are going to build this circuit, and then you do the same steps. Okay, so you want to delete your V2 and V3 and short that to ground. So short this to ground, and then you run the transient simulation, and you take a screenshot. Okay, so that will be your way out 1. Okay, then you do the same thing. Okay, you short V1, short V3, and treat V2 as your only input, and you simulate the way out 2. Okay, and then V3, and then the final way out when these 3 voltage sources all turn on together. And one thing you need to pay attention is the V2 will be a triangle wave, but since you're using AD2, since you're using LT space don't have a triangle wave. So you will need to use a pulse wave to generate a triangle wave. Okay, by change the T on time to 0, you can generate a triangle wave. Okay, yeah, that's task 4. Yeah, for task 1 and task 4, just make sure you take the screenshot and put that into your report. Okay, then let's talk about the task 2 and the task 3. The task 2 is equivalent circuit design. So question 1, you want to design the circuit in this figure that the equivalent voltage is 2.5 volt and the equivalent resistance is 1.5 kilo ohm. So what that means is when you measure the voltage in here, that's 2.5 volt. And when you measure the resistance at this 2 terminal or cross this 2 terminal, that should be 1.5 k ohm. Okay, so how you can calculate this value? There are different methods. Okay, so I can show you the method I was used. Okay, so first of all, I want to satisfy the equivalent resistance. Okay, so I want to make sure my RTH equal to 1.5 k ohm. Okay, so what I do is when I worry about the RTH, I can short Vs. Okay, so the circuit will be looks like this. And I can simplify this circuit to something like this. So this is simple to see. This is R3 in series with R1 and R2 in parallel. Okay, so this circuit should have a resistance of 1.5 k ohm. Okay, so that's the first thing you want to make sure. Make sure you have correct equivalent resistance. Then I will worry about the VTH, the equivalent voltage. Okay, so I transfer this circuit to something like this. Okay, so when we worry about the VTH, and when we want the VTH to 2.5 volt, what that mean is when I put a voltmeter at my output, I should able to reach a 2.5 volt on the voltmeter. And when you measure voltage, you use voltmeter, and the voltmeter have a very large input resistance or very large impedance. Okay, that means there is no current. Okay, so there is no current goes through this path. Okay, because this thing has a infinite resistance. Okay, infinite resistance means no current. Okay, then when there is no current goes through this voltmeter, that means there is no current go to R3. And when there is no current goes through R3, that means the voltage at this side of R3 will be same as this side of R3. Okay, so this node here have same node, same voltage as here. Okay, so in that case, we know we don't worry about R3 when we calculate the VTH. And we can simplify this circuit to something like this. Okay, this seems familiar because this is a voltage division circuit, which you done something in last week and also in task 1 and in pre-lab. Okay, so then the VTH is related to R1, R2, and VTH. I mean, Vs here. Okay, so in this case, you have two equations. Okay, one equation for RTH, one equation for VTH. And you have four variables. Okay, R1, R2, R3, and Vs. So you will have many solutions. Okay, there are many solutions for this design. As long as you choose the correct answer, that should be fine. Okay. All right, so that's question number 1. How to calculate the values. Then question 2 is ask you to develop a method for measure a two-terminal network. Okay, what that mean is you will give a black box. Okay, for example, this is a black box, and there are two lines. Okay, so this is like a cable you can touch with, and what's inside this box is a resistor in series with a voltage source. Okay, but you don't know what's the value for this resistor, and you don't know what's the voltage of this voltage source. The only thing you can get touch with is this 2 pin. Okay, then you can think about a method that you can find out the value for these two components, the resistance and the voltage. You can use DMM to measure the voltage. You can use ammeter to measure the current, or you can use the DMM to measure the resistance. Okay, whatever the method you use, you need to find out the equivalent resistance and the equivalent voltage. Okay, so what I want you to write down here is you can write down a step-by-step method. Okay, so like 1, 2, 3. And when another student check your answer for this question, he or she can follow your steps to do the measurement. Okay. Yeah, so that's question number 2. And question number 3, you build this circuit. Okay, use whatever the value you designed in question 1. You build the circuit on breadboard and apply the method on question 2 and verify the design. Okay, so you should have these two values. And the question number 4 is simple. You draw the equivalent circuit. Okay, so yeah, that's task 2. Okay, then the task 3, buffer. Task 3 is like kind of continue with task 2. So after you finish task 2, don't remove your circuit on breadboard. Okay, you will use those circuit in task 3. So task 3, question number 1, question number 2 is continue with task 2. Okay, so this is a circuit from task 2, and the only thing change is you use a DC voltage in task 2, and you will use a AC voltage in task 3. and you put a 516 ohm resistor as output, and then you measure the output voltage. Okay, so that's question number 1 and question 2. Okay, and then for the question 3 and question 4, you will need to put a buffer in between this resistor and your equivalent circuit. Okay, so this is this part is the buffer. Okay, so how you can build a buffer is you can always build a buffer with the op amp. Okay, so in this question, you will use LF3556N, which you should already search the datasheet in pre-lab. Okay, you will use this component to build a buffer. Okay, so if you find out, okay, if you check your lab kit, this op amp is something looks like this. Okay, and then this is the pin layout, and you see this little, the half square thing. That's indicate the direction. Okay, so for example, that's same thing as here. So on the left of this thing, that's pin 1. That means this pin is pin 1. Okay, so pin 1, pin 2, pin 3, and pin 4. Okay, so that's pin 1, 2, 3, and 4. Okay, so I think so. This is the first time I think you build IC on the breadboard, so it's maybe hard to get started. So if you have any questions, just let me know, and or let other team know. We can help you to build this circuit. So as I mentioned, this is an op amp, and you will use this op amp to build a buffer. And this is a circuit diagram. Okay, so this label, okay, those number with the circle in here is corresponding to the pins in here. Okay, so first of all, after we build the equivalent circuit, we can start to build the buffer. Okay, so the buffer, the input of the buffer is connect to R3. Okay, so we will connect R3 to positive input. Okay, the positive input of the buffer is the pin 3. Okay, so as you see, I label the pin 3. And then the negative input of the op amp is connect to output. Okay, then the negative input is pin 2 and the output is pin 6, which means you want to connect pin 2 to pin 6. Okay, then we worry about the power supply. Okay, don't forget you need a power supply to power up the op amp or the buffer. So you have a plus 5 volt, okay, the positive power supply, that's pin 7, okay, pin 7. And you have a negative power supply, negative 5 volt, that's pin 4. Okay, you can use V plus as your positive power supply, V minus as your negative power supply. Okay, one important thing in here is you don't want to flip these two pin. Okay, always pin 7 is positive input. That should be always positive voltage. Pin 4 negative power supply. That should be always negative voltage. If you accidentally inverse these two pins, for example, you input a negative voltage here, positive voltage here, what will be happen is you will break this chip. Okay, so it will burn. So you don't want this happen. So what I usually do is I build this circuit first before I turn on my power supply. Okay, when I build this circuit, I always turn off my power supply. And before I turn on my power supply, I will double check my circuit, make sure the connection is correct. Then I will turn on my power supply. Okay, yeah, that's how you build the circuit. And after you build the buffer, you connect the 516 ohm resistor. One side of the resistor connect to output, which is pin 6. Another side of the resistor connect to ground. And then you measure the output voltage. Okay, yeah, that's question 4. Question 3 and question 4. Okay, yeah, I think that's all for Lab5. I think, yeah, remember this is the first time you're going to write a formal report. So please check those documents for how to write a lab report. And if you have any question about the tasks, you can let me know, or you can attend the office hour. Okay, so yeah, that's it for today.